Hi, how you doing? Welcome to the super high-tech lesson. Woo! Okay, so what I've got here is I'm just projecting a grid on here because what we're doing today is parabolas in standard form, how to plot parabolas, starting at the very basic beginning. Okay, so parabolas in standard form. Now, standard form for a parabola is y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. But because this is the beginning of the whole thing, I'm just going to do where a is 1. So just x squared plus something, x plus something. Okay. So the first thing that you need to look at is y equals x squared. Alright? So if I look at y equals x squared, that means whatever my x value is, I square it to get my y. Okay? So if x is 0, 0 squared is 0. 1 squared is 1. Negative 1 squared is also 1. 2 squared is 4, right? Negative 2 squared is also 4. 3 squared is 9. It's off my graph. So my parabola for this, for the original guy, y equals x squared, looks like that. Okay. Alright, so that's a very straightforward, that's the original function, y equals x squared, right? Now let's take a look at plotting using coordinates, just like what we did with the straight line graphs. Let's look at the coordinates for plotting our example, y equals x squared plus 2x minus 1. Okay, so all that I'm going to do is exactly like a straight line graph. I'm going to choose a random number of points, okay, and I'm going to plot them. Right, so I'm going to choose x and y, and I'm going to choose a random point. So I'm going to choose negative 2, negative 1, 0, 1, 2. Okay, let's just take 5 points. Right. Now, the working is on the notes there, but let's just look at this and try and do this in our heads. Right. Negative 2, I'm going to replace x with negative 2. Negative 2 squared is 4. 4, negative 2 times 2 is negative 4. 4 plus minus 4 is 0. Minus 1 is minus 1. You're with me? Negative 1 squared is 1. 2 times negative 1 is negative 2. 1 minus 2 is negative 1. Minus 1 is negative 2. Right? 0. 0, 0, minus 1. Because if I put 0 in for anything, it just makes it 0 whenever I deal with multiplication of powers. Right. 1. 1 squared is 1. 2 times 1 is 2. 1 and 2 is 3. Minus 1 is 2. With me. And then 2 squared is 4. 2 times 4 is 4. 4 and 4 is 8. Minus 1 is 7. Use a calculator for this if you're not 100% sure. And these are my coordinates that I'm going to plot. So I'm going to plot negative 2, negative 1, negative 2, negative 1. There's that one. Negative 1, negative 2, negative 1, negative 2. There's that one. 0, negative 1, 0, negative 1. 1, 2, 1, 2. Alright. And then 2, 7. 2, 7, 2, 7 is up here. Alright. Now, if you notice something, you'll see that parabolas are symmetrical about the turning point, meaning the lowest point. So there's the lowest point. This can fold over to that. It looks the same. So if this is the lowest point here and it's starting to go up, that's symmetrical with that. Okay, well, then this one must have a symmetry over here. Alright? Without having to plot that point, I could just see it. And then this one must have a symmetry up here. Also without having to plot the point. Now, all I need to do is run my pen with a free hand. No, it's hard on here. It's easier on a piece of paper, trust me with this. It's hard on the board. Okay, run my pen through that, and there's my beautiful, lovely straight line parabola. Okay, this is y equals x squared plus 2x minus 1. Fantastic. Okay, so if you can see, when you start to look at the transformation of functions, it's good to start to understand how this is a shift there, especially when you change this by completing the square into turning point form. The turning point moves from 0, 0 down to negative 1, negative 2. Okay, when you get into more advanced stuff with that, you'll start to understand that. For now, this is intro into plotting it. Coordinates, putting down coordinates, joining the dots, freehand. Okay, now the other thing that this leads to is the fact of the turning point of what I just said. My turning point is this coordinate, negative 1, negative 2, negative 1, negative 2, alright? And in this case, it's a minimum, alright? It's the lowest the parabola can go. Alright, let's look at one where it's a maximum. Okay. let's look at one where it's a maximum. Okie dokie. So, right. We still have y equals x squared. Now, y equals x squared, I've put it on the notes so you can see it there. It's the one in red. But now I'm just going to jump straight on to the one that we're going to look at, e.g. y equals negative x squared plus 2x plus 5. Okay. Right. Now, first thing, we're doing this via coordinates. So just choose random coordinates, okay? The one I've chosen are the same as the previous ones. I've got negative 2, negative 1, 0, 1, 2. Alright? So those are the coordinates I'm going to do. Right? So when it's negative 2 squared is 4, negative 4. Negative 2 times negative 2 is negative 4. Negative 4 and negative 4 is negative 8. Plus 5 is negative 3. Okay? Or put it into a calculator. Alright? Negative 1 squared is 1, negative 1, right? Negative 1 squared, negative 1. 2 times negative 1 is negative 2. Negative 1 and negative 2 is negative 3. Plus 5 is 2. 0, all of this, 5. Okay? By the way, this is my y-intercept. C is my y-intercept all the time. Okay. 1 squared, right, is 1. Negative, that's negative 1. 2 times 1 is 2. 2 and 1 is 1. Plus 5 is 6. Okay, and the last one you can check is 5. Alright, so let's plot these. Right, so negative 2, negative 3, it's over here. Right, negative 1, negative 2, negative 1, 2, it's there. 0, 5, 1, 2, 3, 4, 5, it's there. 1, 6, it's there. And 2, 5. Now again, you should be able to start to see the pattern. Now let's use symmetry, okay? So 1 across from here is over there, so 1 across from there, it's got to be there. Right? This one has to be symmetrical with that one. So you've got this symmetry that's going through. So now I can neatly join the dots, freehand, and make it a nice curve, alright, through there, there. Alright, so this now is this equation, y equals minus x plus 2x plus 5. Okie dokie. Alright. Now, you should be noticing with this, you should be saying, oh, so look, this now has a turning point of, the turning point is 1, 6, that's the turning point, and it's a maximum, okay, it's a maximum turning point, because it gets to the highest point, that's the most it can go. I can never get 7, do you understand this? I can never get y equals 7, because it'll never reach 7. Look, the highest it goes is 6. So the biggest y I can possibly get out of this is 6. It's a maximum. Okay, and this leads me on to a very cool little note there that I've got there. Alright, so positive graphs are happy. They have a minimum, a lowest point. Alright, so positive graphs mean positive a value, the number in front of the x squared, alright, are happy. They have a minimum value. Negative graphs, meaning if a is negative, negative graphs, well, negative people are sad. Negative people are sad. They look like this. They have a maximum. Now, this part is fine. Positive graphs are happy, negative graphs are sad. Fine. And some people get confused with minimum and maximum. This is counterintuitive, okay? Because normally you think, oh, if I've got a maximum amount of something, then I'm going to be happy. You know, if I've got a maximum amount of money, I'm good, happy. Yeah, but it's counterintuitive. So you're actually looking for the minimum amount of work. Then you'll be happy, okay? All right. Or vice versa, okay? So positive graphs, if A is positive. So if I said to you, okay, well, fantastic. What about y equals 2x squared? Well, is that a positive or a happy graph? Just quick guess at this. Well, A is positive, so 2x squared looks like that. Y equals negative 1/3 x squared. Well, it's a negative a, so negative 1/3 x squared will look like this. And when you, let's touch the x-axis and down. Okay, all right. When you start to get more into it, when you start to understand it, you'll start to look at how, when that gets bigger, the larger you make a, the absolute larger you make a, so the value of the number, as that gets bigger, so the graph gets narrower. Okay, it gets steeper quicker. As it gets closer to 0, notice how I didn't say smaller, because negative 10 is smaller than 2, but it's going to be still quite close. As it gets closer to 0, so the graph flattens out, alright? And you start talking about the gradient of the graph, you start dealing with differentiation in it, and how the graph flattens out or how it gets steeper, you start to look at those things, okay? But for now, all that we're looking at is plotting this guy using coordinates. Simple. Plug into here, plot on there. Done. Okay, there's so much to do with parabolas. I love parabolas, it's really exciting. Okay, parabolas and quadratics. Okay, right, well, there you go. Quite proud of myself with this, fixing this. Cool. Alright, go check some more, and remember, I'm here for you.